Hey guys, welcome back. This is Middle School Math with Dr. Koenig, and today we are talking about systems of equations. Now, there are three methods for solving a system of equation. There's graphing, there's substitution, and there's elimination. So this is part 3 on this series. If you're looking for help in the first two, I'll link those to the end of this video. Otherwise, let's jump in with this method. Here we go. Now, I've got a system of equations, and what I want to do is put them together in a way that eliminates a variable. So let's take a look at this method, and then we'll really dive into how it works. So with elimination, you actually want to add your two equations together and see what happens. What I like about this method is that something cancels itself out. So here I have 4x and I'm adding to it a negative 4x, and I know that 4x plus negative 4x is 0x. So my elimination method has eliminated my x variable. If I keep going, I can add my 3y to my 2y to get 5y. I can add my 15 to 30 to get 45. And now I have something with one variable that's solvable. So to solve, I would divide by 5 on both sides, and I would find that y is equal to 9. Now remember, that's not the final solution to my system because a solution is a set of coordinates. So I now know one of the coordinates, but I need to find the other. To find the other, I just plug the 9 into one of these equations. So I'll do the first one. I'm going to plug it in for y because that's what I solved for so far. I found that y is the one that's equal to 9. And again, I can solve algebraically because I have only one variable. 3 times 9 gives me 27. And this will take a little bit more solving. I need to subtract 27 from both sides. I get 4x equal to negative 12. When I divide by 4, I find that x is equal to negative 3. Using elimination, I found that my system solution is negative 3, 9, an x coordinate and a y coordinate every single time. Let's try another. Now, not every system works out perfectly for elimination right away, but there's a way you can make it eliminate. For example, if I added these two together right now, I would get 4x and 3y. Nothing was eliminated. What I can do to change these equations and make something eliminate is to multiply one of them by something. In this case, I'm going to multiply the first equation, every piece, by negative 3. So it'll need to be distributed to everything. Now I'm doing that because when I multiply the x term, I end up with negative 3x. And what did I have in my first equation? Positive 3x. That's going to get me the elimination that I was looking for. I'll go ahead and bring that second equation over just so you can see it. Now in the first equation, I don't get to just multiply the x. I have to multiply every piece. So now I have negative 3x minus 3y equal to negative 6. Make sure it goes all the way across that equal sign. Now when I add my equations together, my x's are going to give me 0x. That's a good thing. Negative 3y plus 2y is negative 1y, and negative 6 plus 15 is 9. And then I can divide by negative 1 to get y by itself, which tells me that y is equal to negative 9. Again, I still need to go back and plug that negative 9 in to figure out what x is equal to, but at least I'm halfway there. I'll plug it into the first equation. It really doesn't matter which one you plug it into. Look for the equation that looks easiest to deal with. In this case, I'll have x plus my y, which I now know is negative 9, equal to 2, which is really equivalent to x minus 9, right? X plus negative 9 is the same as x minus 9. I'm going to add 9 to both sides to get that x isolated, and that helps me figure out that x is equal to 11. So the solution to my system is 11, negative 9. Here's another example, and hopefully you're noticing negative 4x and x don't cancel, 4y and a negative y don't cancel, so I'm definitely going to need to manipulate these equations in one way or another. Now the goal is to find the easiest thing for you. I noticed that if I multiply this second equation by 4, I'd get a 4x, which would go nicely with my negative 4x. So that's exactly what I'm going to do. I'll go ahead and keep my first equation the same. I could multiply both equations, but sometimes that makes things more complicated than necessary. On the second equation, I'm going to multiply, and I'm going to multiply everything. So I'm multiplying my y also, and I'm multiplying my 5. Now I can go ahead and add my equations together, but what I'm noticing now is that my x's cancel, which is great, but also my y's cancel. 4y minus 4y is 0y, so I'm really left with nothing on the left-hand side, and I'm left with 32 on the right-hand side. So that's why this is one of our special solutions. 0 equals 32. That's not a true statement, which tells me that these equations have no solution. Now, if you think back to learning how to graph system of equations, what that means is these two lines are completely parallel. They have the exact same slope, which means they're never going to touch. They're rising at exactly the same rate. They never meet. And our clue that there's no solution is that we get something that is false when we're solving. All of our variables have canceled out, and we get 0 equal to 32, and 0 is not equal to 32, so there's no solution. Let's take a look at one more. Now again, I'm trying to show you every solution type, and there is one more solution type that you probably know by now called infinitely many solutions. And that's when you have two lines that are completely overlapping. In fact, they're the exact same line. They might be written in different forms, but they have infinitely many solutions because they have every point in common because they're the same line. They're overlapping. Now let's go ahead and solve this one and see what that looks like algebraically. I need to multiply something. It doesn't matter much what I multiply. I know that if I multiply my second equation by 3, I'm going to get a negative 6x, which is good because in my first equation I have a positive 6x, and I know that's going to cancel. I'll go ahead and distribute everything here. I'll get a 9y, and I'll get a negative 18. On the first equation, I have 6x minus 9y equal to positive 18. So what you should be noticing is that there's a lot of commonalities in these two equations. So 6x minus 6x, that gives us 0. Negative 9y plus 9y, that gives us 0. So on the left side, we have nothing. On the right side, 18 plus negative 18, also 0. Now in this situation, we have something that is true. Everything has canceled. 0 equals 0. That's true, which is different from the last solution type where we got something that was not true. We got 0 equal to 32. Here we got something that is true. 0 does equal itself, and that's our hint that we have infinitely many solutions on this example. Now, you've got 3 methods to choose from when you're solving. You can graph, you can use substitution, or you can use elimination. Elimination is my preferred way when I've got 2 equations that are in standard form. No variable is isolated, then I'd immediately start using elimination. You might see something that looks like this. You might see 2x plus 3y equal to 12, and let's say 4x minus 2y equal to 5. That's a great time to use elimination over substitution because it's really easy to leave those in their form and just start multiplying. In this case, if I multiply by negative 2, I know that my x's will eventually cancel. So elimination is useful in that. Remember also that you have 3 answer types. You might have 1 solution, you might have no solutions, and you might have infinitely many solutions. So here are some clues for that. You have 1 solution on a graph when your lines meet. They have a point in common. They look like this. Doesn't really matter which way they're going as long as they meet. When you're solving algebraically, you get an answer. So you have an answer like 3, 4. Another answer type is no solutions, and that's when you've got parallel lines. On a graph, they look like this, and you might recognize it when they're in the system because they have the same slope. When you're solving algebraically, you know it's no solutions because you get something that's not true. You might get that 12 is equal to 6, and we know that those are not equal, so that tells you that this system does not have a solution. The last solution type is infinitely many solutions, which I keep abbreviating for the sake of space. That's when you've got 2 lines that are completely on top of each other. In fact, they're the exact same line. They have infinitely many solutions because they have every point in common. Now, when you're looking at the equations, you might recognize it because your equations are exactly the same. They have the same slope and the same y-intercept. So I'm going to write down here, same equation. When you're solving algebraically, you'll know because you'll get something that is true. So your variables still cancel out, but you get something like 12 is equal to 12. That's true. That tells you that there is infinitely many solutions. So I hope these 3 videos have helped you in your solving systems journey. I hope you're enjoying your time here. I thank you for being here, and I'll see you next time.